Hey everyone, and welcome back to another video from the Waste Tutor. This is the last video of the functions topic, so we're going to be taking the functions topic to a close in this one, which is quite exciting. And we're actually not going to be dealing with functions in this video. We're going to be dealing with relations, which we kind of introduced in the previous video where we conceptually defined what a function actually is. So in terms of the unit overview, it only lists two relations that we're going to be dealing with, but I also want to revisit the concept of the vertical line test and why that is able to differentiate between functions and relations, because I think that's an important conceptual basis for relations. And once I've done a bit of a recap of the vertical line test, I'll move into how we graph relations and how we can determine equations of relations given graphs, specifically for circles and also for, I'll call it a horizontal parabola. So let's get straight into it. Okay, so the first thing I want to talk about is the definition of the vertical line test, which isn't actually included on the kind of the syllabus dot points here, but I think it's important nonetheless. And it's a recap of what we kind of dealt with in the functions topic, or the question where we posed what is a function and defined it conceptually. So generally when we're dealing with functions or just anything linking one variable to another variable, we're dealing with a domain of all the x values commonly that we can assume, and we look at it passing through some kind of machine and being mapped over onto corresponding values in the range. And so the set of outputs collectively are referred to as the range, and the range generally is referred to in terms of a variable y because we work in a Cartesian system. And the important thing is that an input into the domain, an input from the domain more specifically, gets mapped onto a unique output. You can't have an input being mapped onto one output and then also another different output, because in that case it wouldn't be a function. And more specifically in that case, if for example we have the square input being mapped to a triangular input output, or also being mapped onto a circle, that is what we call a one-to-many relation. And more specifically, our one here is our input, and we have several different outputs. And so if we look at this with respect to a Cartesian axis, we have our y-axis, we have our x-axis, and if we're looking here, for example, and this is a horizontal parabola, we can see that this is our input here. Let's say this is -1, and our input gets mapped onto this point here for y, or this point here. And in this case, we can see this is a one-to-many relation. And so in order to test whether something is a function or is a relation, what we can do is we can do a vertical line test, and if the vertical line intersects with your function or relation more than once, then it is considered a relation. And if it only passes through once, it is considered a function. So if we look again here, for example, if we have a parabola, a quadratic formula, we can see here that at any point it will only pass through the parabola once. However, if we have something like the horizontal parabola we were dealing with here previously, we can see that a vertical line, in this case specifically, passes through twice. And so as a result, this is not a function, this is a relation. It should be noted as well that, for example, if we have something like this, and it appears to look like a function for most of it, and then it has this section here. Even though this one section here exists, as long as this one section exists, we know that a vertical line test here passes through once, but here it passes through 1, 2, 3 times. And as a result, this is a relation rather than a function. Okay, so now we've come to a definition of what a relation is. We can transition over to some examples of relations that we can represent graphically on a Cartesian plane. And that's kind of what we're talking about with these dot points. And so let's move to the next slide. So the two common relations that you deal with in the methods course, and I think these are the only relations you really deal with in terms of graphing and determining equations from a graph, are circles and horizontal parabolas. So the first thing I'm going to deal with is the circle. And what a circle is, well, you know what a circle is, but on a Cartesian plane, it will look something like this. It will have a center defined by A, B, and it will have a radius, which we label as R. And so this is on a Cartesian axis, an xy plane. And the equation of this circle will be defined as x minus a squared plus y minus b squared equals r squared. And so we can read, based on this equation, that our center of our circle is a b, and our radius in this case is r. And importantly, that r value is positive, because you can't have a negative radius. So for example, if we had a circle that was defined by the equation x minus 3 squared plus y plus 1 squared equals 9, okay, we know that our center of our circle, in this case, will be equal to 3, and because there's a plus here, it's minus 1, so 3 comma minus 1. And our radius here, this value 9, I didn't write that 9 very well, this 9 value here will be equal to radius squared equals 9, which means solving we can get r equals plus or minus 3. However, since radius is a positive value, we know that it'll have to be equal to 3. So our radius of this circle is equal to 3. And if we wanted to represent this graphically on a Cartesian plane, it would look something like 3 over here and minus 1 down here. And so we would have a center here. We would have a radius of 3, so this would extend back to 0 and up to, sorry, this should be a 3, right? 3, up to 6. We also extend up to the value 2 up here and the value negative 4 down here. And if we connect all of this up, we get a circle centered at 3, negative 1 with radius 3. Okay? We also can have circles written in slightly more complicated ways, and that involve, for example, completing the square or using the quadratic formula. For example, we might have something like x squared plus 6x plus y squared plus 9y, or let's make this 8y equals 1. And in this case, what we need to do is we want to get it into the form x take a squared plus y take b squared equals r squared. And so the way that we do that is we complete the square for this x component of the equation and this y component of the equation. And so if we look at this, we have x squared plus 6x, we can write that as x squared plus 6x, and by completing the square, we know that a perfect square will have to comprise of two numbers that are collectively sum to 6 and are also the same number, and those two numbers need to multiply to form the constant. The way that we find two of the same number that sum to 6 is just by dividing 6 by 2. And that means our two numbers are 3 and 3, the same number. 3 times 3 is 9, and so this is our perfect square. Because we've added 9, we need to subtract 9, and for our y squared component, we similarly do 8 divided by 2 is 4, so plus 8y, and then 4 times 4 is 16, minus 16 equals 1. And so we have completed the square for both of these components. If we factorize x squared plus 6x plus 9, we get x plus 3 all squared. We get y plus 4 all squared. And we have minus 25 equals 1. And so as a result, we get x plus 3 squared plus y plus 4 squared equals 26. And if we look at this, we know that we will have a center equal to negative 3, negative 4, and a radius equal to the square root of 26. And generally, if you're asked in a test to graph this, you will actually have a integer value for radius. It's very rare that they ask you to graph something with a square root, because I think generally that's a little bit difficult to graph. So expect, if you're asked to graph a circle, it will generally have an integer value radius. Okay, so one of the things I will just briefly go over is the horizontal parabola. And with a horizontal parabola, I don't think you should expect to see transformations of the horizontal parabola. You just graph like the very easy basic y squared equals x. But regardless, I'll have a quick look at transformations of the horizontal parabola. And so if I have my Cartesian axis like this, I have my x values, I have my y values, and I have my parabola y squared equals x. The 1 here will correspond, the y equals 1 corresponds to an x equals 1, the y equals 2 corresponds to an x equals 4. And basically it's a parabola, a quadratic form, it's only doing the reverse to each other. So if we have y squared equals x, we can rewrite that as x equals y squared. And so if we have x equals y plus 2 all squared, this will essentially involve a shift 2 units in the negative y direction. And so commonly when we have y equals x plus 2 squared, for example, generally what that looks like on a graph, so we have y equals x squared here, and then when we have the x plus 2 squared, we shift 2 units over to the left, so in the negative x direction. And similarly, if we're looking at this one here, what this will look like is we have our initial graph y squared equals x, and we have y plus 2 squared equals x, shifting over in the negative y direction by 2 units. Okay? Similarly, if we look at a horizontal translation, we have x equals y squared, and then we go to x minus 3 equals y squared. We can rewrite that as x equals y squared plus 3. And in this case, we have a horizontal shift of 3 units to the right. So if we have our initial function, x equals y squared, if we have x minus 3 equals y squared, that'll be 3 units in the right. And so we shift over like this. And so that's everything to do with horizontal parabolas. We've covered circles as well. Something I should mention with circles as well is like one of the defining characteristics of circles is that the coefficients of our x squared term and our y squared term are always going to be the same. If we have different coefficients, so for example, let's relabel this x squared as a triangle. If triangle does not equal square, then we will have an ellipse, and it'll look either like something like this or something like this. And so the precondition of circles is that the coefficient of the x squared term and the y squared term are equal. Okay, so in this video we recognize the features and determine the equations of circles. We also had a look at the horizontal parabola. So we had a look at our horizontal parabola y equals x squared. We looked at the circles and translations. The x squared plus y squared equals r squared is simply the circle that has center 0 and has a radius r. So this is the most basic form of the circle. We also had a recap of the vertical line test at the start to define what a relation is in the first place. And so otherwise, we have finished everything we needed to do right here. So, I just wanted to say again, thank you for watching. And this is the last video of the functions topic. So the next section of the methods course that we're going to be progressing to is arithmetic and geometric sequences and series. And then we'll be moving on to calculus, and that'll do us for year 11 methods. The next video where I start arithmetic sequences is going to be released in 2 days, on the 9th of November. I just wanted to say subscribe so you don't miss that video, and comment if you don't understand some kind of concept or I've missed something. And I'm hoping for the year 11s who are about to head into their semester 2 exams that this is at least a little bit helpful to you. Thank you.